Hey everybody, Dr. Nelson here. This is a lesson on something called perpendicular lines and equations. Okay, so the first couple pages, there's going to be some notes for you to take, and then at the end there's some problems for you to try, and then you can see how you did finally at the end. So what exactly are perpendicular lines? Okay, well here's an example of two lines that are perpendicular. And so we have the purple line, and we also have the blue line. If you notice, when they intersect, one has a positive slope and one has a negative slope. But more importantly, when they intersect, look at the angle that it creates. It creates this right angle. Okay? So when two lines intersect and they create right angles, you know that they're perpendicular. Okay? And you probably knew that already before. But now we got to look at the equations of perpendicular lines. And they certainly have a key characteristic. Okay? So if you look at this first blue line, notice the slope is 2. And if you look at the purple line, notice the slope is negative 1/2. Alright? When we multiply the slopes of the two lines, you should always get -1 when the lines are perpendicular. Okay? So think about it. The reciprocal of 2 is 1/2, but for it to be perpendicular, it has to be -1/2. Alright? So we could say the product of the slopes must be -1. Alright? So here's another example. Let's say we had one line that had a slope of 4. Okay, so 4 over 1. And I wanted to write an equation of another line that is perpendicular to this one. Well, if this is the positive slope, well, the second slope has to be a negative, and it has to be the reciprocal of 4, which is 1/4. Alright, let's do one more. Let's say, for example, we have a slope of 3/5, and I want to write an equation that's perpendicular to this one. Well, the reciprocal of 3/5 is 5/3, and because this first slope is positive, this one here has to be a negative slope. Alright, so please turn the page. So let's try some problems now about perpendicular lines. Alright, so the first thing it says, write and graph an equation perpendicular to 3x plus 1. So let's first graph 3x plus 1. So we're going to have a y-intercept of 1 and a slope of 3. So up 1, 2, 3 over 1. 1, 2, 3 over 1. And let's also go down 3. 1, 2, 3 and left 1. Down 3 and left 1. And let's carefully connect the dots. Alright, so there's our line y equals 3x plus 1. Alright, so again, we need to focus on the slope. So if the slope is 3, we know that the slope of a perpendicular line is going to be -1/3. And then we can use really any y-intercept. I'm going to use just +2. And I'm going to use actually a different color here. Let's go with blue. So I'm going to start off at 2. And this time we're going to have a negative slope of 1/3. So I'm going to go down 1 and then right 3. 1, 2, 3. Down 1 and right 3. We also go up 1 and left 3. And carefully connect the dots. And if you notice, mine's a little bit messy, but we have some right angles here. We have 4 right angles that we create when we have two lines that are perpendicular. Alright? Alright, last but not least, let's look at this problem. It says true or false. 8x plus 4y equals 8 and y equals 1/2 x plus 1 are perpendicular. Well, again, we need to focus on the slope. So this slope is 1/2. So we know that the slope of this equation has to be -2 for it to be perpendicular. Alright, so I'm going to rewrite this here. So 8x plus 4y equals 8. Now I'm going to write it in slope-intercept form. So I'm going to take away 8x. Take away 8x. So now we have 4y equals -8x plus 8. I'm going to divide everything by 4. And when I reduce it, we get y equals -2x plus 2. And look at that, our slope is -2. Alright, and because -2 times 1/2 gives us that magic number of -1, we know that the two equations are perpendicular. Alright, now that you have a good understanding of perpendicular lines, why don't you pause the video and try the Your Turn Now problems. And then when you're done, hit play, and you can see how you did. All right, good luck. All right, welcome back. Let's see how you did with these perpendicular line problems. Okay, so the first problem, you had to write and graph an equation perpendicular to y equals -3/4 plus 1. So let's first graph this. So we're going to have a y-intercept of 1, and then a slope of -3/4. So I'm going to go down 3 over 4. And then let's do it again, down 3 over 4, be kind of over here. I can also go up 3 and left 4. That's there. And let me connect the dots. All right, so there's our equation. Y equals -3/4 x plus 1. All right, now in order to create a line that's perpendicular, I need to rewrite another equation with a slope of 4/3. All right, and we can have really any y-intercept. So I'm going to say 4/3 x plus 2. So I'm going to use a different color here. So I'm going to start at 2, and then we're going to this time have a positive slope. So we're going up 4, 1, 2, 3, 4, over 3. And we can also go down 4, 1, 2, 3, 4, and left 3. I just want to connect the dots. And there it is. Okay. Again, let's give it the quick eyeball check. Well, remember, perpendicular lines create right angles. And this looks pretty square to me, so that's going to be correct. All right, the last one, true or false? Y equals 5x plus 4 and 1x plus 5y equals 10 are perpendicular. Okay, so again, we need to focus on the slopes. So this one has a slope of 5, which means this one over here needs to have a slope of -1/5 for it to be perpendicular. So I'm going to rewrite this here as 1x plus 5y equals 10. And then let's isolate the y, so I'm going to take away 1x from both sides. And we get 5y equals -1x plus 10. And then divide everything by 5. And we get y equals -1/5 x plus 2. And if you notice, the slope is -1/5, right? Which is what we wanted, right? So the answer for this one is true, that the lines are perpendicular. All right, how'd you do?